Okay, talk a little bit about vision. This is how your eye sees things. It's pretty much just like what we've been doing, except we got to look at the parts of the eye and how it works. Basically, your eye has four things that help you out to see: your retina, the lens, the cornea, and the pupil. Okay. The retina is like your CCD. This is where the image is formed. That's what detects the image. The image plane, you can call this really a plane. It's curved, which actually makes it a lot better for getting clearer images than if it was just flat here, with the way a lens system is set up. Your lens ear actually bends the light some. Most of the bending of light comes from the cornea. The cornea is curved. That's why when they reshape the cornea, when they do laser eye surgery, they can change the focal length really well so they can get a lot of people corrected. My eyes were so bad that they could not they couldn't shave off enough of the cornea, or the pressure inside, the interocular pressure from the fluid inside the eyeball would actually deform the cornea if they took off any more. So they worked over time. They only could correct me to a point, and it still didn't form exactly where it needs to be. I still wear contacts in the state for that reason. And actually what's interesting is they got me as close as they could, but I think my cornea has changed shape because over time my prescription has changed to 25-30% over the last 15 years or so since I've had my laser eye surgery. Now, the pupil is like your iris or your aperture stop. But the lens system on a regular camera like we looked at before, that's the combination of the cornea and the lens. You can think of this cornea and the lens is like that two lens system, as opposed to what we saw previously in section 2. It was a diverging and then a converging lens. Here, the opposite way, it was converging and diverging lens. Here, we've got basically two converging lenses, and we changed the focus. It's a little bit different. Rather than moving the lens further away, it's kind of difficult to do. Alright, so retina is like the detector, CCD. Cornea lens is your lens system, and the pupil is your iris or aperture stop. So you got cameras. You got two cameras in your head, right? It shows you record everything you see, including my lectures. Not just on video. You should record them in your mind and save them so you can recall them as needed, if you're actually paying attention. Now, let's look at this retina. In the retina, there's actually 3 types of cones: red, green, and blue. Green is most sensitive. Why? Because when you look at things, being able to discern green variation is fairly important for, does this look a little different? This lettuce, is it good to eat or not? Is this poison ivy? Does it have a sheen to it? That's a little darker green, that's lighter green. Maybe it's ripe and maybe it's not. Green, over time, became people that could discern green better, reproduced more. And so we've developed a sensitivity to green, because of our environment. That makes sense. Why red, green, and blue? Let me add an E to this blue. Well, you mix those 3 together, you get all the colors. So the retina has those. People that are colorblind, one of these tends to, or a combination of them, tend to not work as well as others. And that's color blindness that people can have. Now, when you deal with the eye, you deal with 2 things. A couple of things you deal with, I should say, are the near point and the far point. Your near point is what's the closest I can get it before it starts to lose focus. Now, if I look at my hand, right about here, it's about close as I can get before it starts getting out of focus. That's 8 or 9 inches for me. In general, for most people on average, you have 20/20 vision. It's about 10 inches or so. Okay? Now, what is the closest point the eye can focus? Now, that's important because we use that for microscopes and telescopes in the next section. For me, before eye surgery, my eyes were so bad, my far point, I put up here, this is my near point, and I'm going to change this. My far point, which is the furthest distance you can see something till it's in focus. And for me, 20 people, that's good ways out there, right? My far point was about 4 centimeters. I couldn't focus until it got that close. My near point was dang right on top of my eye almost. I had really bad vision. Now, the far point, like I said, is the farthest point that I can focus. And so what the eye does, going in between, it focuses. It effectively changes the focal length. This cornea lens system changes the focal length so it can focus between those distances on the back of that retina in our eye, this curved area here. So how does it change its focus? Well, it changes the focal length of the lens. Normally you can squint sometimes and maybe change your cornea. But in general, it changes the lens. So there's muscles in the eye, they squeeze or relax the lens. They push it in and make it fatter, or they pull it tight and make it skinnier. And if you have a fatter or a skinnier lens, you're changing the focal length of that lens because you're changing the curvature. Remember the lens maker's equation of it. So by pushing in or pulling on that lens, we're changing the curvature, we're changing the focal length, so it doesn't matter where you're at. So our eye is doing this all the time. Our body continually runs this thing, runs this loop. Hey, I want to focus. What's that out there? And it'll try to focus. It does that constantly. It's a pretty amazing system. Now, sometimes you lose the ability to focus things way far away. Over time, the lens in the eye loses that elasticity. When you pull on it, it doesn't get skinnier. When you push on it, it doesn't get fatter. Maybe the muscles wear out. It tends to be the eye, if I'm not mistaken. The lens itself in the eye loses elasticity. When you push on it, it just doesn't squeeze out as much. So what happens is, you'll see people, they try to get stuff close to reading, they're like, oh my gosh, I have to bring it back. Because they can't focus real close. People call that old age eyes or something. And stuff you'll see. And when does it hit people? 40s, early 50s. It didn't hit me till my early 50s. I'm 54 now. And about 4 or 5 years ago, I started noticing a little bit. You can actually get contacts. They do things with contacts to work with that. And I've had to deal with it. You're not going to see me with little things where you can look across and looking down. I've never had those. Because I absolutely have to. Another eye issue you can have is myopia. Myopia is nearsightedness. What I was nearsighted. I used to joke around, my nearsightedness was so bad that 200 years ago I'd be a watchmaker. Because it's the only thing I could see in focus. It would be like this, or maybe writing books. I would have been like this on everything to be able to see it before the invention of glasses. And I definitely wouldn't be out shooting and targeting or trying to go out and killing something, for my dinner because I couldn't see it. Now, could I develop things to do that? That's another story. Now, the eye, what happens is it focuses in front of the retina. The lens is too fat. So if the lens is too fat, it's going to focus right here. You could argue maybe this distance here is too long in my head. But in general, it's that lens, we normally consider the lens being too fat. It's got too much focusing ability and it can't pull in enough to make a difference. So what do you need to do to correct that? You need to spread that light out a little bit. So what do they put in front? Diverging lenses. You want that light going out, so when this fat lens focuses, it won't focus here, it'll focus a little bit further back. On the retina, you get the right power of that diverging lens, and you can get it to focus on the retina. And because it's diverging lens, it's thicker on the ends and smaller in the middle. What did I wear when I was a kid? I wore the Coke bottles, the nerd glasses, and to correct my vision. I had to. Now, I couldn't wear contacts because my eyes were changing so much and everything back in the day. I really couldn't wear them. I wanted contacts bad. It's no fun. And of course, you watch stuff you get hit in the face because they're thicker on the ends, you hit the glasses, so you get a ring formed around the eye. All right. That's for nearsighted. So why do nearsighted people wear Coke bottle glasses? They need a diverging lens. Their lens is too fat, its focus is in front, and they need to spread the light out some so it focuses further back there. All right? Some people are farsighted. They can't see near, they see real far away. Some would argue, for like shooting or for many, before telescopes and stuff, being farsighted was a good thing. You need those people to see way far away. Most of the society now, being farsighted, we read a lot. So being able to see near is important. Now, in that case, they call it hyperopia. Farsighted is the eye focus is behind the retina. So this lens here, when it tries to focus to the retina, it can't focus enough. So the image forms back here. So you need to help that eye out, converge that light a little bit better. So what lens do you put in front? A converging lens. This is not converging enough, so you need a little help, so you put a converging lens in the front. And that, rather than focuses here now, light's bending more, it focuses on the retina, where you want it to. Now, that's why you have to have converging. They're fatter in the middle and thin on the end. And what used, movies and everything. These would be the fire starters. Problem is, a lot of times, especially the older movies and stuff you'd see, or the cartoons you'd watch, we're stranded on an island. Where's the kid with the Coke bottle glasses? And they use that to focus the light and start a fire. So the kid with Coke bottle glasses is useful. They don't kill them, eat it, right? The physics is wrong. Diverging lens, nearsighted, spreads the light out. You ain't getting focus on that. Now, the good thing is the Coke bottle wearing kid, the nerdy kid, is smart because he reads a lot. So he knows, hey, why don't we just take a water bottle and we'll use that, fill it up with water, it's curved on the end, shine the light through. And that's our converging lens, and we can hopefully start our fire that way. Now it's useful. So now they still don't eat the fat kid because he's smart, not because of his Coke box, hopefully. The fat lens kid, the nearsighted. Right. It's kind of a joke around a little bit about it, but the reality is nearsightedness, fat lens, you can't do fire starters with Coke bottles, okay? And actually, I have seen, what some of the survival shows, you've seen these guys using the clear bottles, fill it up all the way with water, or fill it just partially. If you let it sit there, it can get to a point where you can start a little smoke with it, if you've got enough sunlight. Okay. That's most of what I want to talk about vision. And the ray diagrams are in the book. They talk a little bit about diopters. I'm not going to get into that, some of the detail for that. Strength of lens is measured in diopters. If you have to get your eyes worked on, and they do for your contacts or for your glasses, they'll talk about the power of that lens in diopters. Bottom line, the bigger the diopters, the stronger the lens. For most people, 3, 4, 5 diopters, it's pretty strong, it's vision. 6 maybe. For my vision, right before I had laser surgery, I was running minus 11 diopters here, minus being, the diverging lens. I was 11 here and minus 13 there. My right one was worse than my left one. So that's really bad vision. That's really bad vision. Now I'm running about 3.5 in both of them, minus 3.5 in both of them if I had blue glasses. Okay? That's vision.